This is going to be board number 2 in the SolderSmoke Challenge Direct Conversion Receiver project. Now this is an easy board to assemble because it only has 5 parts. 3 capacitors, C18, C19, and C20, and then 2 toroids. The toroids are used to make transformers, and the transformers here consist of one side 5 turns, the other side 28 turns. And this is the inductance values for those windings as calculated by Bill and Dean. I want you to go, I'm going to show you this. Oh, this is a what is it? It's a Raspberry Pi terminal monitor, and it's fairly small, but it takes up little space on the work desk here. I want you to go to kitsandparts.com, and once you go to the home page, then look down here and there is a menu item for toroids. Click on it. You're going to get a long list here of different toroids and pricing. Quantities of 25 and 100. 100 pieces is probably going to be a lifetime supply for most of you. You get it at discount, but go ahead, and this is probably the best place on the on the planet to get toroids. I want you to go here and click on toroids ferrite specs with calculator. Then I want you to go down here and click on 260, whereas 250-6. This is the toroid we're going to be using for the 2 transformers in the bandpass filter. Go down here, and this little calculator here will calculate your inductance if you give the number of turns. So the requirement here is for the large number of turns to be 28. So we go and enter 28. Then we go calc, and it goes off and calculates it. It says you're going to need 52.7 centimeters of wire, and you're going to get an inductance of 3.14 microhenries. Going back to Bill and Dean, they got 3.02. So we're going to check this. We're going to measure it. And the way to do that is, of course, to wind a toroid with 28 turns. And I've got this fairly equally spaced, and I've tinned both ends of the wire. To measure it, I'm going to use this LC meter. This is a LC200A, and I kind of, well, it's the only LC meter. Well, I've got 2 LC meters, but this is the one that I like the most. You can find them on eBay fairly cheap. I'm going to measure inductance. I've got 2 leads, and I've got them shorted, and use this to calibrate. So you go and hold down the 0 button. This will 0 it. It says it's calculating, and what it does is it figures out the inductance of the leads so that this doesn't enter into your measurement. Now I need 2 hands here to undo this, so I'm going to put you down. Alright, sorry about that. Now I've got them disconnected. Let me connect one lead to one wire here. well, let me just do this one. Whoops, sorry. Can't do 6 different things at once. Okay, so I've got one lead connected to one wire and the other connected there. So now we're measuring, and we get a value here of 3.188, and the 4th digit here oscillates a little bit. It's probably because of my proximity, but going back here, we got a calculation of 3.14. Here we've got 3.18, so that's pretty close, and it's larger than both values are larger than the 3.02. But all that means is that for me to get this LC combination here of L13 and C18 to resonate or be resonant on 40 meters, may have to lower the capacitance here. We can do a calculation, but I'm not going to worry about it. So we're ready to wire it up, and I wired it up. So here's what it looks like when it's assembled on a PCB. Here is C20, here's C18, C19, and then here's the 2 transformers. The 28 turns is the secondary of this one, but it's the primary of the 2nd transformer. This is my input from the antenna, and this is going to be the output to the mixer. So that's board number 2. Now I'm going to take it out to the garage, and I'm going to cut it loose with a shear along this line, so that'll be the second board. Again, I appreciate some likes. Hope you learned something here. And I'm gonna have to do a separate video just entirely devoted to the toroid. Okay. So for now, thank you for your time and interest, and stay tuned for video number 3. I almost thought I'd lost my camera here, but finally got it to working again. Thank you. See you later. Sorry, I need to do a little add-on here. I forgot. Here is the toroid being measured. Moved it around a little bit. So, okay, it's 3.18. Let's call it that. Many people ask when they first encounter toroids just how important is the surrounding area. Now here, I just have the toroid on a non-magnetic, non-metal surface. It's just made out of wood and some kind of covering. This is my desktop, and you can see 3.177. Let me write that down because I'll forget it. 3.177. Now I'm going to take the printed circuit board, and I'm just going to slide it under here. Let me lift this up and put it on there. So this would be pretty, this would be pretty close to the way the toroid would be positioned in a so-called vertical position. And it's still 3.17 or something. Okay, now I see what the problem is. When I bring my hand next to the leads, I influence the capacitance, and I have to do a separate video to explain how capacitance affects what you measure to be inductance. So, okay, so there it is, vertical position. Now let me see if I can do this without, okay. That sorts the leads out. Let me move something around here. Okay. Sorry. I keep forgetting about the camera. So here we are. I've got a spacing there. Toroid's laying flat on the board, and it's still 3.17. And that's due to the shielding property, the physics of a toroid, that the magnetic field is all inside the winding, and there's very little. In the ideal case, it would be zero field outside, but I've got this gap, so that's the thing. So I just want to show you that laying a toroid on a metal surface. Now, if it was steel or iron, that might be a different case. But this is non-ferromagnetic material, and we'll let it go at that. So this is a reason why in some kits, like the QRP Labs QCX Mini series, the toroids in there are laying flat. And a lot of other places you'll see a lot of other transceivers, receivers, and transmitters, toroids will be laid flat, or they may be spaced vertically. That has very little effect on the inductance. So that's your lesson for today. Sorry I didn't get it in the first pass, but better late than never. Thank you.